There's a notorious problem with defining information within physics, namely that on the one hand, information is purely abstract, and the original theory of computation, as developed by Alan Turing and others, regarded computers and the information they manipulate purely abstractly as mathematical objects. Many mathematicians to this day don't realize that information is physical, and that computers, there is no such thing as an abstract computer. Only a physical object can compute things. And on the other hand, physicists have always known that in order to do the work that the theory of information does within physics, such as informing the theory of statistical mechanics and thereby thermodynamics, the second law of thermodynamics, information has to be a physical quantity. And yet its information is independent of the physical object that it resides in. So I'm speaking to you now. Information starts as some kind of electrochemical signals in my brain, and then it gets converted into other signals in my nerves, and then into sound waves, and then into the vibrations of a microphone, mechanical vibrations, then into electricity, and so on. And presumably will eventually go on the internet. And so this something has been instantiated in radically different physical objects which obey different laws of physics and so on. And yet, in order to describe this process, to say what has happened during this process, you have to refer to the thing that has remained constant throughout the process, which is only the information, rather than any physical thing like energy, momentum, and so on. The way to get this substrate independence of information is to refer it to a level of physics that is below and more fundamental than things like laws of motion that we have been used to in the past, thinking of as near the lowest, most fundamental level of physics. And that's what constructor theory is. It's a level of description of physics, physical laws and physical systems, that is more fundamental than the existing prevailing conception of what physics is, namely particles and waves and space and time and an initial state and laws of motion that describe the evolution of that initial state.